We're going to continue in this video talking about hypothesis testing. So, an automotive company executive claims that a mean of 48.3 cars per dealership are being sold each month. A major stockholder believes this claim is high and runs a test by sampling 30 dealerships, finding an average of 45.4 cars with a standard deviation or sample deviation of 15.4. Is the executive's claim false? Is there evidence at the 0.05 level that the average is lower than claimed? There's a lot of things to unpack here, so let's start. First, the hypotheses. The hypotheses are usually the null and the alternative. The null is assuming the original claim is true. So for us, we begin with a null that, yep, the mean really is 48.3. Now the alternative, we believe, is that it is less than 48.3. We should always use the same number in both of these hypotheses. And the reason is we took a sample of 30. I'm not willing, based on my sample, to say the mean is now 45.4. I'm only willing to say I think it's less than it was, or than that claim. And remember, we should always define the parameter we used. So mu is the mean amount of cars sold. I'm just going to put cars sold per dealership like that. Okay. All right. Then we have the idea of our hypotheses being one or two-sided. And I'm going to come back to this idea. We're doing what's called one-sided, meaning less than, or of course it could be greater than, depending on if it was a different problem or different setup. Not equal or is different means we put a not equal sign there. And a lot of times this is done before we even gather any samples. We just say, well, I know they say it's 48.3, but I'm going to check to see if it really is. Maybe it's different than 48.3. Okay? I'm going to come back to that. All right. The p-value. So how I like to think about this is that this is the probability of the alternative occurring if the null is true. All right, so think about that point care example from the previous video. Okay, this is the when you sample for 1 week. Okay, you took a week's worth of samples, and of course I did a simulation of 100 weeks. And we'll formalize this maybe more as we go. But based on this, 3 out of 100 samples would be 0.9 or below. So the p-value is what's the probability of our sample occurring, being that we began with the assumption that it really was a pound. And in this case, it was 0.03, 3 divided by 100. The probability of the alternative occurring, right, that 0.9, if the null was true. So, based on that, we make a conclusion. We either reject the null or we fail to reject the null. And this is a little bit confusing for people because, of course, a lot of times you think, well, isn't the opposite of rejecting accepting? The key here is we wouldn't have done a test if we had no evidence. So if in fact we run our test and let's say, you know, our mean had been for the week was 0.95. There are an awful lot of samples 0.95 or below, but it was supposed to be a pound. So even though we might say, well, it's not that unlikely, we still have evidence it's less than what it was. So that's why the choice is you either reject the null or you fail to reject it, meaning I don't have enough evidence yet, I will keep collecting. Just like Point Care did by saying, I did a week, let's do a year. Okay? I don't have enough evidence yet, so I'm failing to reject, but I'm going to add or do more. Okay? Now, statistically significant, this is simply a reflection on did you reject or not. If you reject the null, then we say this was a statistically significant result. That doesn't mean it was a significant difference. It doesn't mean like, oh man, this bread weighed half of what it was supposed to. I mean, it's 1/10 of a pound. But it is significant in that it would lead us to rejection. Now, how we reject is based on our p-value and this significance level that's given to us. And I'm going to come back to why 0.05 is kind of the standard in the future. But if the p-value is less than 0.05, less than the significance level, we reject. So like in this Poincare's example, this actually was enough. We would reject here because the p-value was 0.03. Okay? And we would say then that that is statistically significant. So as I said, there are different kinds of alternative hypotheses. This is the same setup for the previous problem, and of course we'd had this claim of 48.3, and our sample yielded this, and we tested this alternative that it was lower than what was claimed. So this was our alternative. But it is possible instead to use the words is different or is not, in which case our alternative would be that the mean is not equal to 48.3. And as I said, that's always kind of a weird, it's always kind of a weird situation to do that when you do have a sample to reference. Why wouldn't you just say it's less? And most of the time you do. A lot of times two-sided samples are before you gather data. Maybe you make some guesses ahead of time, and we'll come back to talking more about one-sided and two-sided. Finally, I just wanted to talk about this significance level. Again, I don't want to get into a lot right now about why we've picked 0.05 or if there are other significance values. The important thing to realize now is that is a kind of a break point that's given to us that we say if something is more unlikely than, in the red case I've written here, 0.05, we don't think that the null is true anymore. And again, remember that the p-value, the calculation it's the probability of the alternative or the sample that we're working with occurring if the null is true. So remember, I set up, this is that same picture from the Poincare loaves of bread problem. I set it up under the assumption of 1 pound being true. So what we've just calculated is what's the probability that his 7 loaves had an average of 0.9 if 1 really is the average weight. Okay, so maybe I could have way better notation here. Maybe let's add, what's the probability that my sample mean is 0.9 if the population mean really is 1. All right? So the lower that probability, the more we believe the null is false. Okay? The more evidence we have. So, we talked about this idea of reject or fail to reject. I just want to talk about how we can make some conclusions. If the significance level is 0.05, if we get a p-value of 0.12, we would fail to reject. Because the p-value is not below 0.05. If it was 0.02, of course, then we would reject. If it was 0.06, we'd fail, but I just want to point out how close we are. And this is the key reason for why we never say accept, we say fail to reject. It's because we are so close to that point that maybe increasing our sample size would give us enough evidence to put us under that 0.05. So really we just say at this point we're failing to reject. And in the p-value 0.01, of course, we would reject. We'll be doing a lot more with hypotheses, hypothesis testing in upcoming videos. The big takeaways for today are writing a null and alternative, knowing what the p-value represents, and making a conclusion based on that p-value, whether you're going to reject the null or fail to reject it.